So plan for today is to intro basic graphing with you guys again, so sine and cosine. Then this weekend, I'm afraid to even say these words, but the assignment you get for tonight is not being tested for a while. Like, graphing's not on this next test. So what I would like is for you to prioritize your homework time. And I want you to concentrate on the homework check that's due this week coming up, and the review that you just picked up when you walked in, right? So I want to warn everybody that this review is not an all-encompassing review. It's not like, well, I'm just going to wait till Monday and she's going to do a bunch of questions about the review and I'll be fine. We are stepping away from that in PreCalc. You guys have to do your homework. That is your practice for your test, okay? So do that first. The review is just supplemental problems, extra kinds of things that we are concerned about. But if you don't do the initial homework to begin with, you're going to be a very sad little puppy when you take your test on Tuesday, okay? So you got to make sure you do your homework. Lesson learned, right? Take out worksheet 9. You're going to be looking at something that looks like this, and we're going to be developing the unit circle, okay? No, I lied. We're going to be developing a sine and cosine graph based on the unit circle. Ignore me. So, someone remind me for my unit circle time, when I have these ordered pairs off to the side here, what do they really truly mean? Like, they look like XY ordered pairs, and they are, but yeah, they're really cosine comma sine. So we have to remember that. So if I'm asking you to graph what's called the sine function, I'm asking you to look at a graph that reflects all of the vertical components of your unit circle. So it's all the vertical changes. So if I think about, these ordered pairs along the unit circle, and I learned my lesson from first hour, we were trying to graph extra points. I'm just going to stick to the basic quadrantial points, because they're easier for me to figure out. This ordered pair here on the unit circle is 1, 0, right? But which part of that ordered pair is the sine? 0, because this ordered pair has a height of 0. But what about this ordered pair up here? What height does it have? 1. So what I'm seeing here is I could take the ordered pairs from the unit circle and I could translate them to what we know as our normal coordinate plane. But in trig, they make your axes look kind of weird because we know that the cycle is going to move off in the positive direction a little longer than, unless we want it to go negative. So we're measuring radians along this axis, and we're measuring height or sine function values in this part. So on this axis, this is 0 radians, and if I do all the quadrantials, that would be pi over 2 radians, and then pi radians, and then 3 pi over 2 radians, and 4 pi over 2, so 2 pi radians. Now if we think about the heights, you guys were telling me this one has a height of 0, 1. What's the height over here? The height, though, 0 again. And then this height, Adam, is -1. So I notice they're going to be fluctuating between 0 up to 1, back to 0, back down to -1, and then back to 0 again. So that's why when you graph your sine and your cosine functions, the basic ones, oh my gosh, I need to use my line tools. These are never going to be straight. They're not going to go any higher than 1 or any lower than -1. So you're going to see a range of -1 to 1. So when I actually go to graph this function, you guys told me at 0 radians, you have a height of 0, so the sine function starts on the origin. And if you're ever in a jam in the middle of your test and you're like, oh snap, I can't remember which one sine starts at, because it happened, think about the unit circle. So at pi over 2, you had a height of 1. At pi, it came back down to 0. At 3 pi over 2, your height was -1. And then 0 again. And then everybody watches with joy as I try to graph a sine function. My graphing has been extra bad today. I'm not usually this bad. I don't know what's up. Not enough coffee. Alright, so this is just one cycle of a traditional, not changed sine function. Remember, it does go negatively though, right? It goes forever. The domain goes forever and ever and ever. Is this an even function or an odd function? And to answer that question, you got to go back and think about your symmetry rules. So this is odd. Very good. If it has symmetry of the origin, which this one clearly does, you have an odd function. Very good. Makes sense. Good to hear. All right, let's talk about cosine. So cosine is, if you think about the ordered pairs in your unit circle, cosine are all the x values. We're on worksheet 9. Cosine is all the x values. So if I think about horizontal change being the x value, at 0 radians, your horizontal change is a 1. So all the horizontal changes could be marked, but since I'm lazy, I'm not going to mark all of them until I get to the next quadrantial. What's the horizontal change up here? 0. Good. And then over here, horizontal change this time. Oh, yep. Keeps going, going, going until it gets to -1. Very nice. So that's what we're going to see. A very similar idea to our sine development, but this time cosine obviously is a different shape. So 0. Take a wild guess what your maximums and minimums are. 1 and -1. And the only change is that cosine at 0 radians, which I'm going to do the quadrantials again. At 0 radians, where does your cosine start? What is yep, the horizontal change is a 1, so we're going to graph our cosine function starting at 1. So at pi over 2, the horizontal change was 0. At pi, it was -1. At 3 pi over 2, it would be back to 0. And then at 2 pi, it'd come all the way back to 1. And then everyone's in for a good time when I graph a cosine, because they're even worse than my sines. Although I kind of nailed that one. Almost nailed that one. That was pretty good. I'm going to take a win on that. Cosine, again, this is just one cycle of a cosine from 0 to 2 pi. Remember, cosine does go this way as well. So what kind of a function symmetry are you seeing there? This is an even function. Good news. That might come up later. Like, much later. Much, much later. Alright, we're going to skip tangent if you're alright with that. We'll talk about tangent like when we talk about tangent next week. Tangent's a good time. Tangent is the weird squiggles with vertical asymptotes. Tangent's a fun one. Alright, so find worksheet 10. We're just going to do 10a today because all we're going to do is graph basic sine and cosine graphs with no phase shifts. So if you remember from your trig experience in Algebra 2 or in trig, phase shifts are when they move right and left, and those get a little tricky. No phase shifts today. So just basic sine and cosine. I will show you vertical shifts though. Alright, so this is stuff out of your textbook. It's all the properties of sine and cosine function. And that's just a lot of information that I don't necessarily know that you need to stare at anymore. It talks about the domain going forever. However, the range stretches between -1 and 1. Sine has a y-intercept at 0 because it starts at 0. As opposed to cosine, whose y-intercept is 1. It talks about all the other intercepts, which I think is a weird conversation to have because so many of our sines and cosines don't have the same period length, so these intercepts don't really happen anymore. So everything kind of after that point I find really not important to us. So I'm just going to ignore it and move on. Alright, so these are your sine and cosine function equations. But the ones that are underlined in red there, those are the kind that we're kind of shooting for, but phase shifts won't be talked about until next week. So we won't start with that until Wednesday. We'll come back to that idea. All right, amplitude. When we progress into applications of trig functions, amplitude becomes really important, and I always equate it with like the power of your sine wave or your cosine wave, because that's usually what it is talking about when we're in applications of science. So a lot of the applications we do are kind of stupid. It's like a Ferris wheel problem. Like, who cares? You're on a Ferris wheel. You're not calculating anything. But there are some really cool applications that actually happen in life that we just don't get to. They're hard. They're a little... Huh? You don't need to calculate how high you are at 3.7 seconds. No, not really. It's not really that important, is it? I mean, if you do, I mean, it sounds like a good time, and you're probably my kind of person, but whatever. So amplitude is half the distance of the range. So I think of it as the distance from the midline up to the crest or the trough of the wave, because I think about like literally a powerful wave. But that's my science-y kicking in, you know. The period length is the amount of time it takes for one cycle to complete. A normal period length for sine and cosine graph is 2 pi, And the significance of that is because 2 pi is 1 full revolution of your unit circle. However, we find out that sometimes in our equations there's a b value, something that's inside of the sine or cosine function that lengthens or shortens the period length. We'll talk about that when we see one. I think it's just easier to show you. And then we are also going to find what's called quarter points. That's how we're going to approach graphing, is we're going to figure out all the pertinent pieces, figure out the quarter points, and that's what we're going to count by. Quarter points is taking the period length and quartering it, so dividing it by 4. The only catch for PreCalc that maybe might be different for your previous trig life is we definitely need you to label your 5 ordered pairs. I know in Honors Algebra 2 they made you do that. They probably weren't worried about that in regular Algebra 2, and I don't know how picky you got in trig, but we need to see them labeled. So now we're all in for a treat because Bruzo has to try to graph. Alright, so one thing I noticed is I don't have any axes. You want to get in the habit of drawing x and y axes, or in our case, radian and y axes, or function axes. Beautiful. So I noticed that this graph has an amplitude of 2, but there is no vertical shift. So that tells me that the midline is going to stay at 0, but your maximum and your minimum lines are where? 2 and -2. Very good. That's kind of straight. So the other thing I notice is that inside of your cosine function, they're using theta instead of x, but they have theta over 4. So what that really looks like, they do this weird thing with fractions. Instead of saying 1/4 times theta, they just smushed it into a fraction. And they put the theta in the numerator. So the b value is this 1/4. B changes the period length. If it's anything other than 1, your period is no longer going to be a 2 pi. B technically tells you how much of a cycle you will have completed by the time you hit 2 pi. So for a lot of kids, what they do is they have an axis, and they label out to 2 pi every single time, which is not smart. Because if I did it on this question, when I go to graph, I'm only going to have like a quarter of my sine or cosine cycle done by that point. So since I control the axis labels here, what I'm going to do is I'm going to find the period. And then I'm going to figure out what I'm going to count by using quarter points. So the period is normally 2 pi, but not this time because you're supposed to divide it by the b value. So in our case, that'd be divided by 1/4. But I need you to go back to little kid grades with me. How do we divide by 1/4? Multiply by 4 over 1. That works too, right? So the true period length of this graph is 8 pi. We're going to get through one complete cosine wave by 8 pi. You can count by quartering that. So you take the period and you divide it by 4. So for us, that would be 2 pi. I know some of you do the trick of like, here's 0, here's 8 pi, and then I just half and half it again. That does not work when you have phase shifts. So we're going to do this method instead, okay? So here's 0, and then I'm going to count 1, 2, 3, 4 more, counting by 2 pi. So we have 2 pi. What's next? 4 pi, then 6 pi, and look at the area. Ended at 8 pi, which is where you should end because that's the length of the period. Okay, so now I just have to remember what exactly I'm graphing. I'm graphing a cosine graph, has no reflection. Think about your unit circle. The first cosine value at 0 radians starts where? Up here at the maximum. Very good. So 0 radians up at 2, and then it follows a really nice cyclical pattern. So, and then I gotta try to graph it. My kids always told me these look like horseshoes. I know. I mean, mine don't. What I don't want to see from you is, unfortunately, I'm really bad at this too. Like sometimes kids make them look like V's, like really jagged. That's not right either. They're supposed to be curvy. And essentially a sine and a cosine graph are the same shape. Just a cosine and a sine. It's like if you took a sine graph and shifted it over a certain amount, you would have a cosine graph. So they're the same. They're supposed to both look curvy and wavy, and mine don't look anything like that. But I did forget something really important, guys. I didn't order label any of my ordered pairs. So you know what this graph could use? A bunch of labels on it. Then no one can argue with me, right? It's going to be messy, but you know what? I don't think there's any saving my graph. So I'm just going to label them straight on here. I'm going to be like, this is 0, 2, and this guy is 2 pi 0, and this guy is 4 pi negative 2, If it bothers you that your graph is messy when you do this, you can label them off to the side. I personally feel it's easier to label them on the graph because they're right there. It's like the location, you know. 6 pi 0, and then 8 pi 2. Ta-da! It's all coming back to you now. Today's an easy graphing day. Nothing crazy happens today. All right, so this time we have an amplitude of 3. I notice that there's no vertical shift, so your midline's still going to be at 0. However, they're going to change the period length on you, so we'll get to that in a minute. All right, let's start graphing some stuff. We need to use some lines. Oops. Oh no. Undo. Undo, undo. You know what? Just undo the whole thing. Undo this problem. Try that again. I guess I'll just use that line. There we go. Sure. All right, so midline's at 0. I'm not going to do any markings there. I'm just going to use the axes, but my maximum and my minimum lines are going to be labeled as what? 3 and negative 3. Good. And I should label my 0 on the axes there for the horizontal piece. Or horizontal axes. When you guys do your homework on worksheet 11, all the axes, it's from a computer program, so everything's already graphed for you and it's like labeled, which I find really irritating because I like to be in control of my labels. So I still do all these steps and then I got to figure out like, oh, I'm supposed to mark 3 pi over 8. Like where the heck would 3 pi over 8 be? And then I find that very annoying. So on the test, we don't do that to you and we let you just kind of control your own labels, okay? So let's talk about the period length. It is no longer a traditional 2 pi period. It's 2 pi divided by the b value, so 2. And that means my period length is pi, which kind of makes sense, knowing that this 2 means I would have had 2 full sine cycles by the time I hit 2 pi. So, yeah. All right, quarter point. Take that period and quarter it. So pi quartered would be pi over 4. This is what you're counting by. So every time I make a mark, I'm going to add another pi over 4. Starting from 0. So my first mark is going to be pi over 4. And then my next mark should be 2 pi over 4, which you can write down, but you're going to have to fix in a minute. Can you just simplify that for me? Yeah. And then next would be 3 pi over 4, which is fine. And then finally you would have 4 pi over 4, better known as pi. Thank you. Hey, look, we ended at pi like we were supposed to. So now I have to remember what I'm graphing. I am graphing a sine function. Sine functions begin at the origin, yeah, or at the midline, good. And then they follow the pattern that you would expect from a sine function. Yeah, pretty close. All right, so now I have to go back through and I have to label all these ordered pairs. Apologies. So this is at 0, 0. This guy is pi over 4, 3. This one is pi over 2, 0. This one is 3 pi over 4, negative 3. And this one is pi comma 0. Whew.
What's the quarter point? Divide by 4 to get the quarters.
K just means that's what I'm counting by. Like I can multiply by like a bunch of integers, like 1, 2, 3, 4. Yeah. You don't have to put that down. Good question though. Oh boy, there's a lot going on in number 3. They just really threw you in the deep end for a minute. Negative. What does that do? Going to be reflected, okay, across the radian axis. What's your amplitude? Good. I was trying to trick you, but I didn't. The amplitude is 1/2. Notice Taylor said 1/2, not negative 1/2. The amplitude is always the absolute value of the number in front. The negative is just the reflection that you already identified, okay? So there's going to be a question on an upcoming test where it looks like this, and it's like, what's your amplitude? And if you write down negative 1/2, you're going to get it wrong. All right, so let's get some axes down. Not what I wanted. You know, if I was smart, I would have already had axes drawn for myself. Then I could have avoided all of this. All right, so again, we got a no vertical shift, so I'm just gonna, oops, that got weird. Little labels. I know my midline is 0. What are my maximum and minimum lines? Yeah. And then extra weird here, we have a period length that is most definitely not 2 pi anymore. Yeah, 2/3 pi. Okay, so that's weird. Now I got to take that weird period and quarter it. So if you took your period of 2 pi over 3 and you tried to divide it by 4, another way of dividing by 4 is to multiply by 1/4. That's the same thing in 5th grade math, right? So this fraction simplifies to pi over 6. You could either cross cancel the 2 and 4, or you could just simplify 2 over 12. So that means you're going to be counting by pi over 6s. So that's not too bad. We've done worse than that. All right, starting at 0, 2, 3, 4. So 1 pi over 6. The next one should be 2 pi over 6, which you're welcome to write down, but I do need you to fix it at some point. What's 2 pi over 6? Yeah. And then the next one would be 3 pi over 6, but again, I want you to reduce that. Yeah. And then 4 pi over 6. Which again reduces to 2 pi over 3. Oh, looky there, the end of the period. Okay. So now I got to graph cosine, and normally my cosine would start at my maximum line, my top amplitude line. Except what's special about this cosine? It's been reflected. So we need to start down here at -1/2. And then continue on with the pattern for cosine. I don't know about me graphing this one, guys. Let's see. Okay, got a little weird. Finish strong, though. That's what's important. Okay, so my ordered pairs, like this one right here. This is 0, -1/2. This guy is pi over 6, 0. That's a 6. This one is pi over 3, 1/2. We got pi over 2, 0. And 2 pi over 3, -1/2. That's really ugly. I'm sorry. All right, but here's the thing. I labeled them so no one can come through and argue with me because I'm like, boom, labels. They trump any ugly graph, okay? Whew, that is an ugly graph. Let's move on. Number 4, finally, something new. We have a vertical shift this time. Now, I know I'm not really that picky of a teacher in general, but I think we should start developing some better habits for graphing. I know like in Algebra 2, I don't care what the kids do as long as they label things. What we really should do is still draw axes like we always do when we graph. So draw axes, and remember that everything's going to be shifted up 3 when you draw these axes. So when I do that, I'm going to kind of draw my axes in a way where they're shifted so I have more room up top. And then the midline is no longer going to start at 0. It's going to be at up 3 units. So what I would like you to do is actually draw that midline off the axes like it's supposed to be. I know sometimes your teachers just let you like draw 3 lines, and as long as you label, you're good. Technically, that's true. It's just not good habit. So my amplitude is 2. So when I go to mark in my maximum and minimum lines, they're at 5 and 1. Very good. Okay. Now, for me, you've seen my graphs. They're not great. So when I go to mark up the quarter points on the axes, I literally put them on the axes. I don't mess with this stuff because this is going to be ugly enough. It needs all the help it can get. I do notice, however, that inside of the sine function, there's no b value that's going to change the period length. So your period length is going to stay at 2 pi. Which means your quarter point would be that 2 pi cut into quarters, which reduces to pi over 2. And that's what we're going to count by. So along these this radian axis, I'm going to count pi over 2, which basically I'm counting the quadrantals of the unit circle. This is a traditional rotation, right? Pi over 2, and then instead of 2 pi over 2, better known as pi, 1 pi over 2, 2 pi over 2. Next would be 3 pi over 2, And then the last one, 4 pi over 2, better known as 2 pi. Now, as you do your homework, if you already know that pi over 2, like you know the cycle of it, you don't have to think really hard, right? Like if you know it's a 2 pi period and you know the marks are going to be the same thing, that's fine. The trick is going to be when we get into phase shifts next week. You might have quarter points that count by pi over 2s, but then everything's been shifted to the right pi over 4, and then you got to start thinking really hard about what that means, okay? Shape, sine, where does sine start?
Origin.
Yeah, his midline. So at 0 radians, it starts at the midline, so it's actually start up at 3, and then follows its normal pattern after that. And you can graph all the points you want on Bruzo, but now you got to actually graph the line, and this is going to be bad. I've done worse. Okay, so now I'm going to label my ordered pairs. This is at 0, 3. This guy is at pi over 2, 5. This guy is at pi, comma 3. This one is 3 pi over 2, comma 1. And then this final ordered pair is 2 pi, comma 3. Again, if you don't like the ordered pairs on your graph because it's ugly enough, then you can list them down the side. That's fine. I like them on the graph. Covers up my ugly graphing. Oh, we're doing great for time, guys. Anything you want me to go back to? So far, so good? I sure can. Gotta clean off the glasses and then think really hard. Okay. Alright, this time, got a vertical shift of down 4, so when I draw my axes, I gotta keep that in mind. Have everything kind of shifted in a way where I can draw down 4. What's the amplitude? There is a 1 there, yeah. So, definitely want to leave room for being able to move downwards in my vertical axes. The midline, I'll just pretend it's there, even though it's not. And then my maximum and minimum lines are going to be 1 unit above and below that. So, I don't know why I made this so small. That was really stupid. That's okay, I can move everything. Okay, so this is not even to scale anymore, but I don't care. This midline, remember, was at -4, and if our amplitude was 1, that means this maximum line is up here at -3, and then below that would be a -5. No one can argue with me because I labeled them, right? Even though it totally is not to scale. Who cares? All right, so we're going to figure out our period first before we find the quarter point. Again, they did that weird thing with the fraction, where inside of this cosine function, it really says 1/2 times theta. So your b value is really a 1/2. So if you were looking at a graph, by the time you hit 2 pi, it's only going to get through half of its cycles. So we got to go further than that. So period is 2 pi divided by half. But guys, we don't divide by half. What do we do, 5th graders? Multiply by the reciprocal. So multiply by 2. And that means our period is really a 4 pi. So then we find our quarter point. Oh, that's going to be nice. You take this new period of 4 pi and you quarter it. Y'all, we got to count by pi's. I can do that. All right, starting at 0, we're going to have 1, 2, 3, and 4. So 1 pi, 2 pi, 3 pi, and 4 pi. All right, what do I know about this graph? It's a cosine. It's normal, meaning it's not going to be reflected. And here we go. Cosines start at their maximum line. So 0 radians is up here at -3, and then from there we just move along. And then I ruin it by trying to graph. Hey! Look at that! Go me. I'm going to keep that one, like forever. Alright, so this, well, now I'm about to ruin it. This ordered pair right there, that guy is at 0, -3. This guy is at pi, comma, -4. This one is at 2 pi, -5. This one is at 3 pi negative 4. And then this final one is at 4 pi negative 3. Whew. And then I think they got one more problem, the big kahuna at the end. It's got a lot of stuff. What's the amplitude, though? Let's start there. Hmm? You guys are giving me about 7 answers.
72.
What is the amplitude? 3. I know, but then Taylor's like 1, and then I was like, no. And then I got 72 at one point. So the amplitude is 3. So then the kid who says the amplitude is negative 3 is wrong because the negative is part of the reflection component. It's not part of the amplitude. Okay, that's annoying. So let's talk about graphing this. Let's get some axes. This one does have a vertical shift of up 1, so I do have to consider that. And the amplitude is 3, so we are going to go positive and negative here. It's kind of straight. So my midline, now we're going to be up here at 1. And because you guys told me my amplitude was 3 units, I need to mark a maximum line at 4. And then this guy, what we will call negative 2. Because I say it is negative 2. Labels are a bad grapher's best friend, right? No one can argue with your labels if you label it. I mean, I could. Like, if you wrote negative 2 in the positive area of your coordinate plane, I might have an issue with that. All right, let's talk about the period length. Oh, it's our traditional 2 pi period. Which means our quarter points, if you already have it memorized, cool beans. If not, you just take the 2 pi and you quarter it, which means you're going to count every pi over 2. So I label those on the actual axes. They got 1 pi over 2, 2 pi over 2, better known as pi, 3 pi over 2, and 4 pi over 2, better known as 2 pi. What am I graphing here? Sine. So sine's supposed to start at the midline for his graph. So this at 0 radian starts up at 1. And then sine normally goes up, back to middle. But you're going to yell something at me. You're going to say,
No.
it's been reflected. So instead of going up, I got to, oops, go down. Just put a little flipsy zero on it, right? Every time. I think I've forgotten the reflection enough where kids have yelled at me, and now I'm traumatized by it. So now I remember to do the reflection. All right. And then I ruin it because I can't graph. No. Okay, so this ordered pair is 0, 1. This guy is at pi over 2, negative 2. This guy is at pi comma 1. This guy is at 3 pi over 2, comma 4. And then finally we have 2 pi, comma 1. Whew. And that's about as challenging as it's going to get. But like I said, the worksheet 11, go ahead and turn to worksheet 11 for a few reasons, just to look at what I'm talking about, but also to circle the problems that you're supposed to do for homework, because I don't think they are circled. You'll notice on worksheet 11, like all the graphs are there and they're labeled, which actually is not good news, because that means you have to go figure out where the line is supposed to be, and like that's your line and that's your marking. I find it irritating when the graphs are done, but whatever. Same process though, guys. You got to identify your amplitude, your period, your quarter points. You got to eventually label your 5 points. Go ahead and circle the problems you're supposed to be doing for homework. And again, this sounds like bad advice coming from your teacher, but I'm going to tell you that you should probably wait to do this homework because you have other things to think about. You got to prioritize your time. So the first thing you need to do for me between now and Monday, you need to finish up that homework check, guys. We have designed this in a way where we're not going to be so like, oh, I'm not going to touch the homework and then I'll just do the review and I'll figure it out because I'm a smart kid. That's not the way trig is going to work, and especially the new stuff that's coming up where you've never seen it before. So you are going to do your homework first. That's really what you're doing to review for this test. The review that you picked up is just some supplemental questions for extra examples of things that we think you might want to look at. So that's in addition to the homework, not in place of it. And then you're also studying for your unit circle test this weekend because you're going to have that on Monday. We're going to ask you to consider graphing the general shape for sine and cosine on the back of the unit circle graph too. It's not going to be necessarily a portion of the score. We're thinking about what to do with that. It might just be like an exit ticket. It could be a bonus score. I haven't decided yet. I'm thinking about it. Okay. Yes. Monday, last 10 minutes of class. It was today, and then we moved it. We said that a few times, but you might have been dreaming. Taylor too. Well, Taylor was probably sick the first time we said it, and then she was recovering the next time, and she's just now back to 80% probably. Poor thing. I don't know what your problem is, Jacob. Right. Oh.